Hello, Algebra students. It is time for our next lesson. In the Do Now, I'm asking you what are the next three numbers in each sequence. So there's a few ways you can do these. Some of you might recognize some patterns here, some of you might not. If we go from 1 to 4, you realize we're adding 3. From 4 to 9, we're not adding 3, we're adding 5. From 9 to 16, we're adding 7. From 16 to 25, we're adding 9. Oh, it's going up every other odd number, right? So that means with this one, we would have to add 11. With this one, we'd have to add 13. And in this step, we'd have to add 15. 25 and 11 is 36. 36 and 13 is 49. 49 and 15 would be 64. Or maybe some of you realize, wait a minute, 1 squared is 1 times 1. 4 is the same as 2 times 2. 9 is the same as 3 times 3. 16 is the same as 4 times 4. 25 is the same as 5 times 5. So 6 times 6, 7 times 7, 8 times 8 would fill in those blanks. It's a nice pattern to notice. In the second one, if we go by adding, we're adding 5, then we're adding 10, then we're adding 20. That's that same pattern over again. So adding might not work so well. What about multiplying? To get from 5 to 10, multiply by 2. 10 to 20, multiply by 2. 20 to 40, multiply by 2. That's a pattern we can follow. 40 times 2 would be 80. 80 times 2 would be 160. 160 times 2 is 320. Finishes out right nice. And in fact, sequences like that second one are what we're going to deal with today in Lesson 9-8. Lesson 9-8 deals with geometric sequences. A geometric sequence is a list of numbers in which the ratio of consecutive terms is constant. The ratio of consecutive terms is constant. That means terms that are right next to each other, you're going to multiply by the same thing every time. We're multiplying by the same number every time. So to get from 1 to 3, we would multiply by 3. 3 to 9, we'd multiply by 3. 9 to 27, multiply by 3. 27 to 81, we multiply by 3. And so our constant ratio in this example would be 3, because that's what we're multiplying by every time. If you weren't sure what you were multiplying by, you could go the other way and divide. 81 divided by 27 is 3. Or 27 divided by 9 is 3. Or 9 divided by 3 is 3. Let's check this one. To get from here to here, here to here, here to here, here to here. If you're not so sure, go the other way and divide. 4 divided by negative 8. Well, 4 over negative 8 can be reduced if I divide top and bottom by 4. I get 1 over negative 2. And negative half is that ratio. 64 times negative half. Positive 64 becomes a negative 32. Half of 64 is 32. Do it again. Half of 32 is 16. The negative changes, alternates that sign. Half of 16 is 8. Half of 8 is 4. No problem. So this would be the common ratio for this one. We're always multiplying. In this case, we're always multiplying by negative half. Multiply by negative half. So a geometric sequence is a list of numbers, and to get to the next term or the next number, you're always multiplying by that same ratio. So, in your assignment, they're going to ask first, is the sequence arithmetic, geometric, or neither? Geometric means you're multiplying by the same number every time. Arithmetic means you're adding the same number every time. And neither means neither. So to get from here 20 to 15, are we multiplying? 15. Looks like we are subtracting 5 or adding -5 every time. And because we're adding that same number every time, that means this one is arithmetic. This one, adding 5, adding 3, adding 6. That's not arithmetic. What if we multiply? Multiply would get 9/4 or 12 divided by 3. Remember, we could go backwards. Or 18 divided by 12. That's 3/2. That's 4. That's 2 1/4. None of those are good or the same. So this one is a neither. How about this one? To get from 2 to 8, 32 to 128. That's right, we're multiplying by 4 every time. That means this one is a geometric sequence. And our common ratio is 4. But in your assignment, they're just going to ask you arithmetic, geometric, or neither. In the second time of example, they're telling you, yes, this is a geometric sequence. Now, tell me what the next 3 terms are. It's a little bit like the do now. What are we multiplying by every time here? If you're not sure, if you can't figure out, go the other way. -64 divided by 16. If it doesn't make sense in your head, you can use your calculator. -64 divided by 16. -4. Yeah, 1 times -4 is -4. -4 times -4 is +16. Yeah, that's going to work. So, as long as my calculator is out, I might as well use it. -64 times -4 is 256. Multiply that by -4 is -1024. Multiply that by -4, and I get 4096. These are my next 3 terms. Over here, to get from 9 to 3, 3 to 1, looks like we're dividing by 3. Or we could write that as multiplying by 1/3. That's what we like as mathematicians. What are you multiplying by? Multiplying by a third, multiplying by a third, no problem. 1/3, this guy, times 1/3, top times top, bottom times bottom is 1/9. Do it again, 1/9 times 1/3, top times top is 1, bottom times bottom is 27. Do it again, 1/27 times 1/3, top times top is 1, bottom times bottom is 81. So the next 3 terms are those 3 right there. Fantastic. I've got one more type of example, but before that, you need this magical formula. I know, it looks pretty complex, but it is somewhat math-magical. I just made up that word. It is math-magical. You'll probably want to put this at the top of your homework. A sub n equals a sub 1 times r to the n minus 1. What? I know. Let's go through it step by step. First of all, a sub 1, this guy. That's the first term in the sequence. It's just a fancy mathematical way of saying what's the first term in your list. The next one, the R. That stands for your common ratio. What are you multiplying by every time? Your common ratio. That's that 1/3 on the last page, or that -4. Your common ratio. A sub n is the term you are looking for. Or some people say it's the last term, and which is right there, and then n is the number of terms. Don't worry, you'll pick it up. So we're going to use this formula in this next example. Luckily, I wrote the formula right up here. It says to write an equation for the nth term of the sequence. So we're going to write this guy, but we're going to try to put in every single number that we can. So over here, I'm going to put a sub 1, r, a sub n, and n. A sub 1, remember, is the first term in the sequence. What's the first term in this one? Oh yeah, that -6. What's our common ratio? What are we multiplying by every time? Yep, it's doubling every time, but it's also alternating signs, which means that's going to be a negative there. So our common ratio is -2. It says the nth term, it's not giving us a term, so these ones are going to stay just as is. A sub n and n. And then we plug it in here. A sub n stays as a sub n. A sub 1 is -6. R is our common ratio, that's -2. N stays as n minus 1. To be clear, only this part gets that exponent. You need to take this to that power first, not both of them. So that's your answer for part A. Plug in what you know. Now we're going to take it even a step further, and we are going to find the 9th term of this sequence. So we're going to use this formula, but now we're going to find the 9th term. And if it helps, go ahead and write down what you know. A sub 1 is still -6. The common ratio is still -2. The number of terms, though, we're looking for the 9th term. That means n equals 9. So that means a sub n is actually a sub 9, or the 9th term. And that's what we're looking for. So we could write it as a sub 9 equals, first term is -6. Common ratio is -2. N is 9. 9 minus 1. What's 9 minus 1? That's right, it's 8. So -6 times -2 to the 8th power. Remember, we only take the -2 to the 8th power. So if I'm using my calculator again, I put -2 in parentheses, and then I'm going to use this caret key right here to the 8th power, which gives me 256. So this is -6 times 256. And I can go ahead and multiply that by -6 to get my answer of -1536. What's kind of cool is you could keep multiplying by -2, -96, positive, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could do it all by hand and get that same answer. This is just a quicker way. Good luck on the homework, you guys.